Welcome to Code for Thought. I'm Selena Aragon, SSI Comms Lead, and this is the Software Horror Story series. Today I'm talking to Colin Sauze, a research software engineer at Aberystwyth University located on the west coast of Wales. Colin works on the Supercomputing Wales project, which provides high-performance computing facilities to a consortium of 4 Welsh universities. He works across the university to help researchers make the best use of his system. His PhD was in biologically inspired power management for autonomous sailing robots. After finishing his PhD, he continued his research throughout a 3-year postdoc position, which was then followed by an assortment of jobs such as training, software development, system administrator, and data manager, which eventually led to becoming an RSE. Colin is also one of the people behind the Coding Confessions project, which inspired this podcast. Welcome, Colin. It's lovely to have you here today.
Hi, good to be here.
Would you like to comment on your Coding Confessions project to start with?
Yeah, so Coding Confessions came up as an idea at a hack day from the collaborations workshop run by the Software Sustainability Institute last year, as kind of an idea of how to make it more acceptable that people make mistakes when coding, and that we should talk about these mistakes so we don't repeat them, and so that we maybe don't judge people so much for making them, because we all make these kind of mistakes. And perhaps it's not always obvious to more junior developers that even senior developers are making these sort of mistakes.
Yeah. Okay, so in terms of your horror story, do you want to tell us where you were at the time?
So my horror story was during my PhD. I was working in a lab which is really set up for doing electronics and hardware work. And I was working on building an autonomous sailing robot as part of my PhD. And at this point, we didn't really have much funding towards this project. So this was being built out of spare parts that were found in the lab. And the hull of the boat was being made out of wood. We had some scrap motors out of an old printer that we were using to turn the sails and the rudder. And I had to write the code that would control these motors. And connected between the microcontroller and the motors was a set of power transistors that would switch on and off a much higher current power supply. And when you turn these on, if you had to do it in a certain sequence, the motor would then move a step around. I made a slight bug in my code, though, that left one of the transistors on after the motor had finished moving. And what you need to do is turn them all off. After several minutes, this got rather hot, and I noticed smoke was coming out of the robot.
Oh, no.
And being a wooden robot with a rather hot power transistor wasn't a very good combination.
Yeah, I can imagine that.
So it was all down to me making, a one-line mistake that I basically forgot to set something to 0 after I finished looping through this loop that moved the motor.
Oh. And what happened next? I mean, things started getting on fire.
Yeah, so the transistors were underneath the deck, which was held on, it's a piece of plastic held on by about 12 screws. So I very quickly unscrewed it and I think pulled the power out from the battery. Luckily, it wasn't too badly burned. The transistor itself had burned out. There was a little bit of a scorch mark on the wood, but it hadn't seriously caught fire or anything at that point.
Okay.
I don't think I needed to put any water in or anything to extinguish any fires, fortunately. But had it been left any longer, it certainly would have.
Yeah.
And had it, I not found this bug in the lab and it had actually gone into deployment where we'd had the thing sailing at sea, it could have easily caught fire out of sight and we would have never recovered it in time.
This is a great example of how code can impact on like an actual physical object, isn't it?
Yeah, so my realization at the time was, wow, I just wrote a piece of code that destroyed a piece of hardware. I've never done that before. And realizing actually how easy it was, that all I did was forget one line to set something to 0 and I caught something on fire.
Yeah. And how did your PhD supervisor reacted to this, and how your colleagues or your other peer PhD students reacted to this?
Well, there was actually another student with me at the time watching it, and he's like, is there supposed to be smoke coming out of it? It wasn't too badly reacted to by my supervisor. He kind of accepted that when you're doing hardware things, especially, that things break and problems happen like that. And this wasn't the only problem like that happened, and he caused many similar sorts of problems at one time. Normally the problems were more fundamental in the electronics, actually, that would cause things. But this one was my fault in the software.
Yeah.
And we always had a little bit of a jokey blame game going on that I would blame his hardware and he would blame my software. But it was actually a fairly good, quite accepting culture that things were going to go wrong at times. And that was just part of the nature of doing this kind of work.
That's great. That's really good to hear.
But what we did then have to do was a bit of a redesign. We realized that obviously the code needed fixing so that this didn't happen again, but also that maybe the heat sink on the power transistor wasn't adequate. So we built a very ground up, complete redesign actually of the power system, which took a couple of months in the end because I went totally back to the drawing board. Instead of using a hacked together circuit board that we'd made in 10 minutes, actually designed my own circuit properly. And this actually had 2 sets of power transistors and you could use either one.
Mm-hmm.
And it actually led to some sort of interesting experiments where we tried to flip between the 2 and try and use the one that was getting least hot. So each actually had a temperature sensor against a big heat sink.
Yeah.
And tried to have the analogy going back to the biologically inspired bit that this was like having inflammation in a muscle.
Yeah.
And so as the muscle got inflamed or got hot, you would kind of switch to using the other one. So it's like you're changing arms maybe when you're carrying a heavy bag.
Very interesting. So in the end, there was a pretty good resolution there, even though there were implications in real life from the software you were coding. I'm really happy it worked out in the end for you, Colin. And if you could give any advice to a younger you about all of this, what would that be?
I think in the end, it really helped talking to one of our lab technicians about how to design this thing properly. And I can't remember now if he'd been consulted at all in the design of this or maybe only very briefly, but it would be to make more use of his time. And he had a lot of expertise in designing electronic circuits and probably could have foreseen that this was going to get too hot and that we needed better heat sinking on it.
Yeah.
So it was really to make use of your technicians and RSEs as well. If it's a software problem, to get advice on these things before they become a problem.
Of course. And to end the episode, I would just like to thank you for sharing your horror story with us today. You survived a fire and have become a very successful research software engineer since. If you're listening to this, we'd love to hear your thoughts. Send us a tweet at Quote for Thought with comments and suggestions. This was Software Horror Stories at Quote for Thought. Thank you, and until next time.